It's time to attempt the fourth and final iteration of this Groom. As before, I'm going to drag out a copy of the last iteration, which was the third, and then rename it fourth. In this iteration, I want to take this entire Groom and change the texture of the hair, such that the slicked back hair going into the bun is redone with braids, as well as the bangs. The bangs will be done with some sparse braiding, and the fade will have hair that has a slight amount of frizz applied to it. Diving in, as before, I'm going to take my old solutions and recolor the network boxes to a gray. New solutions will receive a color for this iteration to make them stand out. The braids is the biggest challenge to construct. I'm going to first lay down an L system node. I don't want to start with a very high amount of generations, as I need to create quite a long curve in order to see if this works. To begin, I know that all the angles of my weaving line will be 45 degrees, so I'm going to change the angle in the Values tab to 45. The B variable, I want to shortcut as the step size, which is 0.1, but I'm going to multiply it by the square root of 2, which is the diagonal of a square. Variable C will be the diagonal through a cube with roots of 1 on each side. To do this, I enter channel, open parenthesis, quote, reference the step size, end quote, and then multiply by the square root of 3. To begin with the Rules tab, the premise needs to be cleared from the default L system. And as learned in the brainstorm, I have 3 strands. I'm going to start my premise with a open bracket, negative E, closed bracket. And now I need to build my variables within this code. I'm going to set A to equal plus F plus. Rule 2 will be B, which will equal ampersand F, and then open parenthesis, distance lowercase b, close parenthesis, hat, forward, open parenthesis, C. Variable C will equal hat, forward, open parenthesis, variable lowercase b, close parenthesis, ampersand, forward, open parenthesis, variable lowercase c, close parenthesis. Variable D will equal negative, forward, negative, and variable E will equal A, B, C, and then refer to J. Rule number 6 will include variable J, which will be to add in variables D, B, C, and E. Looking at this in the viewport, I see I have quite the weave happening. From certain angles, it does look like a sinusoidal curve, so this is ideal. As I increase the generations, I can see the pattern continues to build itself as it recursively refers back and forth between E and J. For identification, I'm going to call this the right strand. Dragging out a copy, I can now create the middle strand. All the rules are the same as before. I only need to change the premise. The new premise being plus plus open bracket minus DCE close bracket. Dragging out a final copy, I can refer to the left strand. The premise will be plus plus open bracket negative negative FF plus DBCE close bracket. I will now merge these 3 strands to see what they look like overlapped. They are all stemming out of the origin. Though they have the correct pattern, they need to be slightly offset from one another in order to see this weave come to life. Adding a transform node under the middle strand, I'm going to translate in the X by 0.2 and in the Z by negative 0.15. A transform node after the left strand will be adjusted to translate into 0.4 in the X, and I will clear out the Z translate to be 0 once again. This weaving pattern is perfect. However, the ends of the generations of each of the L system nodes all line up on the same side. I need to adjust these generations so that there's a slight offset to make them appear to end all at once. To control these generations, I'm going to reference them to a separate node, which will be a null node that I will label L-System Controller. Within this node, I can right-click the cog to edit the parameter interface and drag and drop an integer slider. The new name will be generations, and the label, which I'll be able to see from the interface, will be L-System Generations. Clicking apply and accept, I now have an integer slider that I can use to reference into all the L-System nodes. If I copy this and paste relative reference into each one of the L-Systems, the value that was set in the L-System controller can now be seen in the generations of the individual L-Systems. And by dragging the L-System controller generations, I can see all my L-Systems growing up with the view flag set on the merge. Now, I just need to add a small number in order to balance out these ends. Starting with plus 0.3 for the right strand, then the middle will be minus 0.1, where the left strand will be minus 1. And now the end of this L-System weave appears to be balanced between all three strands. Now, with the match size node to go after the merge, I can move this group of three strands to center closer to the origin as far as the X and Z go. And now I will add a transform node after the match size so that at a later time I have the ability to rotate this braid along the Y axis in case it is either upside down or 90 degrees from an orientation that I need later. With an additional match size to follow the transform, I'm going to connect into the second input a line. The purpose of this line is to scale the braid overall. As its direction is vertical in the Y, matching the direction of the braid growth, I need to click Scale to Fit in the match size, and then pick Scale Axis Y. Going back and checking my L-System Generations controller, I can see that as I drag up and down on the generations, the now refit weave continues to grow generations but merely tightens the braid, becoming thinner. With this new L-System weave, I'm going to begin applying it to the guides that are at the top of the scalp. Working back to the hair clump node that came from Guide Advection, I'm going to add a new node for Houdini 21 called Guide Clump Center. This creates an average guide that drives through the center of each clump. This is ideal for applying the braid structure to, as the original clumps can be used to create roots that bind up into the braid, and then the clump center to grow the braid itself. Taking a look at the previous hair clump node, node number 21, I'm going to adjust the profile so that each one of the clumps pinches very sharply at the roots. In order to get more pinching, I will need more guide resolution so that with additional points, I can get that pinch to happen immediately at the root. With this new hair clump node, all I need is a guide process set length where I will adjust the mode to set maximum. And now with the length slider, I can slowly grow out the hairs until they pinch together into a single line. A value of 0.009 works in the case of these guides with this resolution. Going back to my guide clump center, I'm going to add a guide process set length. The purpose for this is to pull back the guide clump centers slightly from where they meet together for how they're bound up before they reach the curves that create the bun. I don't want the braids to come to such a small point. I want them to be a little bit spaced out. So I'm going to set the mode to subtract and then reduce them by 1 centimeter. And now I can see I have a little bit of spacing in between the guides. This is a solution in itself, so I'm going to create a network box and call it Step 10 Create Roots. The output of the guide process set length can be used to pipe back into the step 7 curve to guide joining. I already have the shape of the bun and the solution for how to join the curves. I can simply check the very bottom of this step 7 to see if it works. There it is. Checking to see that the prim's still cut in half from 276 to 138. I can see that the join node is working just fine. This means I no longer need the blast node, as I have an exact multiple of prims and no remainders. Continuing from where the blast node left off, I'm now going to create a for each primitive loop. In this loop, I need a path to form. The second input will be the for each begin, and the first input will be the match size. If I change the forward direction to Y as well as the up direction, I could see that my braids or my weaving L system now follows those clump guide centers with the joined hair at the end. I will change the up direction to the Z instead. And going back to the transform that controls rotation of the weave, I can change it to rotate in the Y by 180 degrees, so the braid seems to be convex instead of concave. The braid scaler can be dragged for the length in order to watch the overall L system grow to fill out the curve. Now I need to create an additional input for the L system controller, so I will drag across a new integer slider and label it size. From here, I can copy and paste relative reference into the length of the braid scaler, but as I do not want this value to climb very high, nor do I want it to start at 0, I will add a 1 and then multiply this entire value by a 0.01. Now dragging up on the size slider, I can see it grow and slowly fill in to the rest of the curve. In the path to form node, the end behavior needs to be adjusted. If I set it to clip, I sometimes get unpredictable results, though it would be ideal to clip the braid at the very end. So instead, I'm going to set it to clamp. Checking the bottom of the for each loop, I can now see that all of these curves have been replaced with L system braids. As I've learned before from the previous iteration, I need to get these braids referenced in order to control the guides. So I need a attribute lookup. Before I do this, I'm going to grab the roots of each braid by adding a subdivide first to smooth them out, and then a group expression, which will run over the points and then take the first point from each primitive, which is a default vex expression available in this node. Now I'm going to add array, and then in the first input with a vex expression, and then the second input with a junction node referencing back to the scalp. I can change the group to the roots from the group expression and set the method to minimum distance. Now the roots are all being pulled down and rayed to the surface of the scalp. From here, a guide skin attribute lookup will take me home with the first input coming from the ray and the second input coming from the wire junction. I now have skin prim and skin prim UV on all of these weaving L systems. Plugging this into the second input of a hair generate with the guides and taking once again from the junction the scalp source into the first input of the hair generate, I could see that I have some curves beginning to grow in the shape of the braids. Now I just need to remember the group of the scalp, or I can uncheck grow unguided hair. Increasing the density to 100,000. Before I begin working with these hairs, I'm going to change my attributes and appearance as before. The thickness will be 300 micron, with the last value of the hair profile being 0.1. All I need to do now is change the maximum guide count to increase the fidelity of these curves. My group, once set to scalp, will show that the braids are limited to the region that I want to work with. With an influence radius tightened up to 0.005, I can finally get these braids to tighten up to the region of each individual input. And now for the look development. To change the L systems and the size is simply for user pleasure to get the final look that looks most appropriate to the size of braids desired. Increasing the density will add several points, as now we are playing around within the millions of points for this hair groom. I can also look at the ends of the braids and see that they end with a kind of curly twist. This is one of the benefits to using the clamp method for the path deform. If I were to go back to the clump size, and that's in the step 2 advection, I can change the amount of braids that will be grown by reducing the amount of clump centers that come from those clumps. This is a perfect solution for adding braids to incoming curves, and so I will give it a network box and call it Step 11 L System Braid. For now, I'm going to reduce the density of the hair gen just to take down the points as I continue to work within this project. And also, the blending method, I believe, looks better when set to extrude and blend under the guide weight section of the hair generate. With every braid should be some flyaway hairs that don't conform to the tightness of the overall braid. To get this look, I'm just going to drag out a copy of node 114 braids, calling it 115 flyaways, and just change the influence radius to be slightly larger while also reducing the density tenfold. Lastly, I want the illusion of some finer hairs. This will cover up some baldness that may happen with these braids. Almost like vellus hair, hair that would be too short to conform to the groom, and if it works well, I'll later also add in the front scalp. I'm going to limit this new hair generate to all of the top scalp. These hairs will not be braided, but they will simply just be curly hairs at the base of all the braids to fill in the gaps. To get the curl, I need to add a hair clump node after this hair generate, and then look development will come after. As usual, the clump size as a default is too large for the size of my model, so I'm going to add a 0 after the decimal. And then in the fractal clumping, I would like to see the number of iterations turn up to 2, and I'm going to adjust the amplitude of the curls until I get a nice wavy density of curls to fill in. Adding a guide process set length, I'm going to shrink this overall groom by changing the mode to multiply and the method to scale. There we have it. Taking the scale factor down to 0.1, I have tiny little hairs that will fill in the gaps. I think this would be a little more convincing with a higher amplitude in the curl. And now to see the overall look, I'm going to connect them all with the merge node. Now I have the flyaways with the braids and the vellus hair. For my clumping, I never like to end with a tip, so I'm just doing a little bit of look development for my own pleasure. And as this looks just fine, I'm going to add the front scalp group back in for the vellus hair generate. And lastly, to add to the merge, I want those roots that was created in that previous step, create roots. Now I have the illusion of hairs that are being drawn up and entering into the braids. It's time to correct the angle of those roots by adding a resample node for the hair clump back in the hair advection. With additional segments, I can get a tighter angle. And now that step 9 hair elastic solution that was used before can be truncated off of the old node tree from the previous bun and connected to this new bun, which involves the braids. I'm going to have to reselect which primitive was blasted to find a suitable area to wrap the hair elastic, but otherwise everything should work as before. As I haven't found a primitive that matches my needs, in the guide volume, I'm just going to change the resampling in order to get more primitives to choose from. This solution is working perfectly. I'm going to drag out a copy and now apply the solution to the banks. As before, I want to create the appearance of some drawn together roots. And I also want to work with guide clump centers that come out of the hair clump node. Connecting this new guide clump center into the for each loop for this step 11 system braid, I can immediately see results. All that remains now is to properly reference the right scalp region, but as the bangs are using the front scalp, and this is within the region that was used before, this junction wire, it can be shared in between both L system braid solutions. I'm now taking a quick peek at the face or the head with the face removed to see how much interpenetration I have of the hairs. Knowing that the guide clump centers are not penetrating the scalp and it is merely the L system braids which create the penetration, I know that I'm just fine for how much the Groom is passing through the geometry of the head. To wrap up this solution, I want to create and drag out a copy of my create roots and bring that over. I had gotten started with a guide clump center, so I can continue to keep that, but I still like the guide process in which I had set the length of the drawn together roots. As before, I want to pinch my clumps together quite dramatically to get the illusion of roots pinched together to draw into a braid. If I'm unsatisfied with the shape, I will simply add a resample and turning off the max segment length and adjusting the max segs to something significantly higher, I can get that starburst look of geometry pinching in together. The set length is already adjusted as before, and it's working just perfectly for these new roots. Great. Now I have the braids, and I have the roots. Lastly, I just need the vellus hair, which was already created in the top scalp solution. In the next part, I'll approach the side scalp to finish this iteration. This is a lot of material for now, so it's time to take a break and maybe in between these steps, continue to play with the settings of the L system generations and the size. I hope you enjoyed creating the solution with me. Thank you for watching.